Welcome to Bugcrowd University's server-side request forgery. So let me just, I have here, I'm Jay, and I have with me Alyssa Herrera, who is one of our Bugcrowd ambassadors. So yeah, I'd just like to introduce ourselves. My name is Jay. That's my Twitter handle, shipcode. I work as an application security engineer at Bugcrowd. So I used to be a bug bounty hunter, and then because of work and my own research projects like car hacking, and because I like to contribute to other open source, so the reason I stopped bug hunting, and because of work and a lot of work, and because of RootCon also, I'm a RootCon goon, which is a hacker conference based in the Philippines. So that's the reason why I get busy. But maybe another time I'll try to do bug hunting again. So I'll switch you to Aliza.
I'm Alicia Herrera. You can find me on Alicia Herrera underscore on Twitter. I'm a web application security researcher, and I'm a full-time bug bounty working on Bugcrowd, Hacker on Integrity, and yeah.
Yep. So yeah, Alisa is, like I said, Alisa is one of our prominent Bugcrowd ambassadors. So she's really good, and she helped me with the slides as well. So this is gonna be great. I hope you guys are excited. So here's the module outline. So we have the introduction to SSRF, and then we have the two types of SSRF, which are external SSRF, then internal SSRF, and then we have a lab URL, which is just a simple demonstration on a sample SSRF vulnerability, and then explanation of external SSRF and internal SSRF on the public URL or the lab URL. And then we have a public disclosure sample of a common SSRF vulnerability. And then we also have bypassing the blacklist. Like, for example, if there's a firewall or a security measure to block you from accessing internal assets. So there are ways to somehow bypass this one. Then for the last one, we have the resources and references that you could look or hit on, so that you could learn more about SSRF, or get to know about the terms and definitions, right?
All right.
Okay.
Introduction. So what is SSRF? And according to OWASP, server-side request forgery basically is a server-side request for a tag. The tagger can abuse the functionality on the server to read or update internal resources or access them in an otherwise unauthorized fashion. The good thing about SSRF, or rather the bad thing for companies, that SSRF can be used to change several different tag vectors together to perform unauthorized actions against internal instances or access sensitive data that might be only internally facing, or as far as going to access credentials in the case of accessing cloud metadata APIs. SSRF can generally be used to port scan, looking for what sort of services are being used on the internal side of the network. It can be used to identify what sort of internal web service they're using, or if they're doing internal administrative panels they're using. You can also use SSRF in the case of using protocol attacks to read local files or leak data through other protocols like the Gopher protocol or Redis. There's various protocols to SSRF that can allow you to perform various actions to leak data. You can also perform port smuggling attacks, as I've mentioned before, or you could smuggle commands to an internal service and use that to perform different types of things. Like in the case of using the Gopher protocol to send legitimate emails from the company's own server without authorization.
Yeah.
Okay.
So it's really, so there's like a minor attack and then a medium attack, and there's also a critical to a high to critical attacks for SSRF. So yeah, it's really a cool vulnerability because you can do a lot of things with it. So, yeah. So like I said, there are two types of SSRF. So I'm just gonna explain external SSRF. So you can actually do outbound connections to a server you control. Uh, you can do a pingback to a provided external URL. So when you control a certain domain, you can actually, if you do an external or make outbound connection, you can see it in the logs of your server. So in some cases, it allows you to get an internal IP or sensitive data through SSRF. And then, of course, you could parse the content of a parameter using an external URL, for example, example.com, and then the parameter is URL. So external.com/check, and the parameter is URL, and then you try to access google.com. So if you try to parse that, it's present on example.com. You can view google.com from the end of example.com. So it's pretty much like you're able to iframe google.com or view google.com from the website of example.com. So it's pretty much like making a request, also making an outbound connection to google.com. In some cases, it doesn't necessarily prove an exploitable SSRF scenario, but in Bugcrowd, because we have the vulnerability rating taxonomy, or the VRT, we usually reward this one with a P4 classification based on the VRT. So it's pretty much good already. If you can't like leverage, so you will have a P4 priority or reward. So, and lastly, in some cases, it provides feedback through error or by design. So, Elisa, I'll get back to you.
All right. Um, so basically, in a more or less basic scenario of what an external SSRF might look like on the server side of things, it might be making a ping command to a user provided URL, or performing a curl command, or doing some sort of lookup on the address itself. Um, this is more or less what external SSRF is. Basically, just a server making a connection to another server that you may control. So
Yep. We actually have a demo for this one later on. We'll show you later. So yep, like I said, you can actually do an external pingback. Yeah, you can, with external pingback, you could also make an outbound request, or you could also um, enumerate the open ports externally. So um, this is actually a common vulnerability of WordPress before. Like I think it's version 3.5.2 below, wherein by using the XML RPC.php, you can actually, for example, from the string here, string HTTP, we have google.com, and then put the port, which is 21. So you can see that the fault code for that one, which is the response, is 16. So that means port 21 is not open externally, but if you get the fault code, which is int17, from the right side of the image, you can see that there's port 80 for google.com. You don't need to specify port 80. So you can see that it has a different fault code. It's 17. So that means that the port is open. And you can see another response. It says there that the source URL does not contain a link to the target URL and so cannot be used as a resource. But with int16 response, which wherein we tried to have google.com and then the port 21, specify port 21, it says the source URL does not exist. So from there, you could actually get an understanding or somehow a feedback that port 21 is not open externally, but port 80 is open internally. So I actually have a sample. So this one is what I reported before from my bug hunting days, wherein I was able to enumerate ports 80 and port 443 for Google externally by using the XML RPC from a target. So I was able to find a valid post for the parameter P and value 1. So I was using WordPress pingback port scanner. So it actually does the same from what you can see in the slide, but it's just that it's automated. So you just need to specify the the target, and then after that the WordPress that has XML RPC. So it's actually open source. You can see it from here. This is actually by Farfart. So I know that name sounds funny, but he's really a cool guy. So it's WordPress pingback port scanner. So yeah, you have there. Well, this is not already. You can't find this on most websites anymore because most WordPress websites are patched right now. But there's also a Metasploit a module for this one. If you want to find it, you just find word search the module about pingback port scanner. You should be able to find it there. So I guess that's it, and I'll get back to you again, Eliza.
All right. So internal SSRF is basically when we're able to tunnel requests internally rather than externally, where we're able to access or ping internal services or access internal network or hosts or stuff that usually resides on the internal facing side of things where most people wouldn't be able to access. Internal SSRF tends to allow you to request internal IPs such as a locally hosted server page, for example. You could also discover internally facing services such as Redis, MongoDB, Elasticsearch, and things like that, which would sometimes be on the internal facing side of things where you wouldn't normally be able to access it. You can additionally forward and route request commands to those services as well in some cases. Additionally, you can also find debugging endpoints as well. For example, sometimes you'll find server, for example, for an easy example, you can find, on some cases, you can find servers that have status running on internal facing side, which are accessible on the external facing side of the server. You can also use internal SSRF to traverse networks and access other IP ranges and servers that might be also be hosted might be hosting adjacent to the server itself. in one example, a researcher was able to access routers of a network as well because they were connected to the same network. Another example is with cloud services, they will have an internally facing API service, which you could also access as well. Internal SSRF is essentially just the ability to access, or rather perform internal URL or IP requests to the server rather than making an external request to an outbound to the server that isn't that you control or somebody else controls. The severity for internal SSRF tends to be on the higher scale due to what you're able to do comparatively to external SSRF, where the severity is quite low, as the ability to simply port scan somebody else's server or simply getting a pingback to your server isn't really having a severity to it, whereas being able to access debugging endpoints, administrative panels, or accessing servers that you're not supposed to be able to access in some cases can lead to data leakage or full blown takeover of the servers itself if you're in the case if you're able to grab credentials from internal facing from the AWS Metadata API, for example. So on to Jay.
All right. So basically, yep, you could leverage your target. So you usually have P2 for this one, but if you could like take over the host because of being able to get the AWS metadata keys, then yep, surely we'll give you a P1 for this one. Or if you could like get some credentials by parsing a data from using SSRF, then yes, that's a P1 issue. So I'll go to the next slide. This is a sample from Atlassian itself, wherein you can actually parse the metadata from an AWS host. So what you can see, that's actually the vulnerable plugin, which is the icon URI for Atlassian. This has been fixed in most Atlassian services for Jira. So right now, you don't see this much, but there are still hosts that are still vulnerable with this one. So we have I have a sample lab that has a different scenario, but somehow it's similar to this one. Tackle that one later on. So basically, if you can test some services or hosts for SSRF if you can somehow find things like if you're able to parse a data, if you're able to parse an image, or if you see some an endpoint that parses a PDF file, then that's something you can actually test for SSRF. So, right, back to you, Alyssa.
So more on the cloud service attacks that you could perform with server-side request forgery with cloud services or internal services as well. But here are some examples of cloud services or internal services that you could access with SSRF, for example. Google Cloud, for one example, gives you the ability to access private keys as well as and for example, Docker or Kubernetes will also reveal API key, internal IPs, or ports as well, as these services would only be accessible to an internally facing server, where you have legitimate access to it and are able to invoke these queries. But through SSRF, we could maliciously request them on our own, basically time, and in most cases, most cloud services don't actually have as much access as Google Cloud or AWS has, for example. Some of them also have their own security measures in place, For example, Microsoft Azure requires headers to be included in the request before it's allowed to be requested, and Google Cloud also requires it, but there is a way to bypass it where you're able to use the beta endpoint, which is still in use for as of today, and it's been used before by other researchers to access it when you normally shouldn't have been able to access it. The other thing with accessing Docker or Kubernetes is that you tend to be able to find more interesting information on them comparatively. And there are more examples you could find on the Swisskey repo, as it documents and lists out various services, what sort of data you're able to aggregate from these cloud services, as well as other alternative things that you could also look for in terms of services. Or on to Jay.
All right, thanks. Yeah, pretty much. It is really good. This is really a good vulnerability because you could parse a lot of data. So now for the blacklist. So in case, for example, the AWS metadata, which is, for example, 169.254.169.254, is actually blacklisted. So I actually, from my experience, I was able to triage a vulnerability in one of the programs wherein the researcher was able to parse the metadata because it's vulnerable, because one of the hosts of that program or scope of that program is vulnerable to SSRF, and he was able to parse the AWS metadata from that host. And the client actually fixed that one, but it wasn't fixed good because he was just blacklisting. So he blacklisted 169.254.169.254, but the researcher was able to use an alternate IP encoding. I think he was using .list decimal, and because of that, he was still able to parse the AWS metadata. So, like I said, because of the bypass, he was still able to get the reward, another reward for the issue that he was reporting before. So yeah, you can turn your old vulnerability into another vulnerability if you are able to bypass it. So here are some bypasses, like for the DNS record, the HTTP redirect, and the alternate IP encoding. So yep, we just need to go to Swisskey repo, and you can see other bypasses, and then you're just gonna fuzz the endpoint with this values, for example.
Another thing with generally blacklists in general is that they tend to not actually be rather they tend to be rather ineffective, as there tends to be a lot more ways to go around them normally, as well as there are also other ways to bypass blacklists, or even in some cases weird home rolled solutions for SSRF. In some cases, you can even abuse redirection in the host itself. If, say, for example, find an issue where you could redirect from the host itself, you can use that redirection vulnerability to redirect to internal facing server, for example. And there are also other cases where you can abuse nuances in the URL the parser itself as well to bypass it as well. In case of Orange Sai, who made a presentation discussing nuances in curl, URL libs, and the like.
Yep, that's right. Thanks for that one. All right, so yeah, there's actually a sample demo. There's a URL. So I've actually prepared it. It's just a simple one. So it's actually from my this one. It's from an AWS host. So basically, for an AWS host, this runs on Ubuntu actually, and I was able to. Basically, you can't access this one. You can't access this externally, but with SSRF, you could actually access this one from the web. So, for example, from this host, I can't access this if I just use this one, for example, right? So it's an internal endpoint for AWS. So I need to be in the host to be able to get this. But with SSRF, because I can parse this one, so yep, I can do something about it. So I have a sample lab. So let's just imagine this is a virus image checker. So take for example, we'll try this one. Okay. All right. So let's wait, and then it parses. It's pretty much like a string parser. So let's just wait. Let me just try burp if it's intercepting it. Okay. Okay. So basically, okay, like I said, just imagine that it's a virus parser, image checker, if it has a virus. So what you can see, we were able to parse. It's pretty much like using strings command in Linux, and you can see this. So yep, it parsed this PNG file. So let's try to somehow use pingb.in, which for example, let's just imagine that we control pingb.in. So we'll try this one to check if we can make a request. So this is a sample of a actually what you call an external SSRF. So you can see the log from here, and yep, we were able to make a request using this IP, and yep, this is the IP, right? The AWS host. Now, this, like I said, this is a sample of an external SSRF. Now I want to dig deeper. I want to leverage this kind of issue. So I'm gonna try to check if I could parse this one from this virus image checker, for example. So there. So I was able to parse the metadata values for AWS. And take note, this is an internal host or service. So yeah, that's something fun, right? You could poke it. So there are other, if you want to know more about the instance metadata and user data, just go to documents from Amazon. And yeah, basically you can retrieve this one if you are in the host. But with SSRF, yeah, can do a lot of things with SSRF. So this is one of the examples, scary examples actually. That's it for the demo. If you want to play with a demo, just play with it. If it gets DOS, I'll just try to restart it. I'll monitor it from time to time, and that's the URL actually. And I'm pretty sure you can do it. So, Aliza, do you want to play with it, or yeah, I'm pretty sure you just want to check on it.
Uh, yeah. Um, yeah. Um, Examples like that are quite common. There's also with SSRF. Um, but yeah, you tend to find things that will either make a request to a server like that, or some of the more common examples of like generally finding SSRF in general tends to be things like stuff that makes like their like webhooks or remote like image uploading, where the server will request an external link to download an image from, or other cases where it's just simply or it's doing it, or it's looking up the command, or looking up the host, or checking to see if the website has a certain text file or things like that. But yeah.
Yeah, pretty cool. In short, it's pretty cool. Yeah, you can do a lot of things. You can forge actually some services like port smuggling, SMTP servers, something like that. So there are still a lot of things that you can do actually. Right? So, Lisa, you want to explain this one?
In another sort of example in Jira is the Jira Trello importer. Basically the Jira instance would make a request to a um, Trello instance, and this was usable to form a SSRF. Um, the issue is rather straightforward, as with all server requests for vulnerabilities, where it's simply where you have a server making a request that a user can modify or change, and this could, and an attacker, for example, could modify the request to form malicious lookups or requests. And in this example, they provided they it was a they so that they mentioned that it was possible to access instance data in an example, for example.
Yeah. So this is actually a public disclosure sample, and you can find it. You can actually search for this one. So yeah, like I said, if you see something that makes a request to something to another host, or import something from another host, parse PDF data, PDF file, or parse another image, another resource, so that's something that you actually want to check for. Maybe you could do parse another host aside from that kind of host. Yep, that's that's one of the endpoints that you could try for looking for SSRF issue. All right. So here are some resources and references for SSRF. Swisskey repo, and then a new era of exploiting your parser threading programming languages. This one is actually created by Orange Chai. Orange Chai is actually a Taiwanese guy. He's also one of the organizers of HitCon, and he actually presented a lot of things about SSRF. He was able to um, report a lot of vulnerability with SSRF, found a lot of techniques, and he's actually considered as one of the SSRF gods. So yeah, he did a lot of things. He has presented a lot of things about SSRF and Black Hat and other hacking conferences. And then there's also an Nginx blog about the perils of trusting user input, which is related to SSRF as well. And then we also have SSRF resources from Bug Bounty Forum. So if you want, like I said, if you want to know more, if you want to add additional terms or know more techniques and more examples that you could play with, uh, you could try reading this. So, and I think that's it. So, Alisa, do you need do you want to add something?
Um, as far as resources go, Orange Side has quite good amount of resources on SSRF. Um, Another researcher that also has decent resources on SSRF is Andrea Baptiste, who had a public report on performing SSRF in Shopify and gaining demonstrated a total access to Shopify's networks through an SSRF vulnerability, and he has also some slides and slides discussing examples of SSRF in various services he worked on as well. I think as far as I have to go.
Okay. And actually, I also saw Alisa that he was able to write some uh, his findings on one of the I forgot I think it's government website, right, Alisa? When you found some internal hosts for I don't know what government website is that, but
I've one of my that on that report I was able to exploit the Jira vulnerability um within a military server, which was able to give me access to internal services that the military were using, and that was a really high severity issue due to data I was able to access and the sensitive internal services I was able to access.
yeah. So yeah, don't forget to follow Alisa as well in his Twitter because he has a lot of things from her end. She has a lot of things from her end. I mean, so yeah, follow her Twitter and then uh, yeah, learn from her. And if you need anything else, just message us on Twitter. It's in the slide about our Twitter URL. Maybe I'll try to improve the public URL, the lab URL, from time to time. So yeah, that's it from my end.
Yeah. Um, yeah, I don't have anything else to add.